Okay, so now we're in chapter 3.8 and we're going to be talking about the center of mass. Okay, so again we have a variable density. We're going to talk about our wire again going from 0 to 4 along our x-axis. Okay, we have a variable density of this wire, which is e to the minus x. It's described by that equation. Now, to calculate the center of mass, right, what we want to be able to do is take a look at where each mass component sits with respect to each x coordinate along this wire. What we've done before in the previous example was calculate out the midpoint of mass without actually taking a look at where each of those x segments were. Okay, so calculating the center of mass is looking at the mass at this x and then basically adding up all of those pieces. Okay, so first thing we want to do is take a look at the total mass of this structure, which is the mass of the left plus the mass of the right, which we calculated before, right? We calculated from 0 to 2 and then from 2 to 4. So I'm going to go 1 minus e to the minus 4. And this is again in the English system, so that's in slugs. Now, when I look at this, right, I've got the mass times the center of mass, the x coordinate for that. So when I do this, I've got 0 to 4. I'm going to integrate along the whole thing. I'm going to take into account each x position, and I'm going to take a look at the change in mass as we go. Now the change in mass is given to us by our length density function times each of those tiny little slivers. Okay, so plugging in each of those bits, that's a 4, there's x e to the minus x dx. Okay, so this is all from before. When I want to be able to integrate this, okay, I'm going to be taking a look at integrating that piece right there. So when I go to do that, I'm going to get minus x e to the minus x minus e to the minus x from 0 to 4. Okay, I'm going to be using integration by parts in order to integrate this. I'm skipping all of that algebra in order just to show you what our antiderivative is from 0 to 4. Okay, when I go to evaluate this, plugging things in x equals 4, x equals 0, I'm going to get 1 minus 5e to the minus 4, and the units here are foot slugs. Okay, so our center of mass, which is basically our x coordinate, is going to be this number divided by the total mass of the system. Okay, so this number here is 1 minus 5e to the minus 4 all over our total mass, 1 minus e to the minus 4. These are just numbers. I can plug e to the minus 4 in my calculator, multiply it by 5, subtract it from 1, and so on and so forth. And when I do that, I'm going to get 0.925 feet. Okay, so 0.925 feet is our center of mass. This is where, right, if I put like a little fulcrum there, this wire is going to balance okay.